So I will be continuing this ray optics. The last day I was telling about the sign convention. Okay, so today I will start with the sign convention. Very important, because with this convention all the numericals have to be done with this type of convention, and if you mismatch this convention, your numerical formula might be correct, values might be correct, but the answer may come wrong. So what I will be doing now, sign convention. Lot of types of sign conventions are there. One is Cartesian type, another is direction type, so what I will do this direction type, because you see the rule is very simple. All directions must be measured from pole. Now remember one thing, this convention same as that for spherical mirror or lens, whatever it may be, whether convex mirror or convex lens or concave lens, even plano-convex or convexo-convex, concavo-convex, what type of lens is there, everywhere you have to use this sign convention. So every measurement of all direction must be started from the pole, and if you go in favor of the ray, this is ray direction and this is the distance. If it is same direction, that will be positive, and if the ray direction is opposite to that of distance, it will be negative. Very simple rule, nothing very hard in it. Whenever I will be doing with an example, it will be very easy for you. Just to remember these things. Only requirement is to remembering this rule. Suppose I am having a concave mirror. Okay. So this is my pole, that point is my pole. I can denote it with a O. This is my F. Approximately I am doing, this is my radius of curvature, which is equals to twice F. Now I have put an object here. Suppose the image is being here. This is my object, this is my image. So I will start my distance from pole. So now the rays are coming from the object to the mirror, so the ray direction is like this. So as I am going against the ray direction, starting from the pole, so my distance will be negative. So object distance here in this case, object distance is equal to negative. Now about image distance, the same thing. I am going from the pole, and again it is opposite to that of incident ray. So image distance is also negative. Now this is the focal length. So if I go for focal length, so again my direction is opposite to that the incident ray. So the f, that is the focus distance, is also negative. So this is the basic rule. Now there might be some other cases where u may be negative, v may be positive. Let me show one example where this change of sign may occur. Suppose you are having a convex mirror. So this was the case of a concave mirror. অবতল দর্পণ. This is a convex mirror. So this is the axis. Here it is the pole. I have put my object here. So the image is formed, say here, and the focus is here. Now obviously the r will be, which is equal to twice f. Now I will start my distance. So this is my object distance. So this will be negative because the incident I am calculating from the pole and the ray is coming in this direction. So they are opposite in direction. You see this arrow, these two arrow representing the oppositeness of that direction. So that will be u. Now this is the image. Now you see I am calculating my distance as mentioned from the pole. Now this direction and this one becomes same, that is I am in favor of the incident ray. So the image distance will be positive, it will be plus v. Similarly the focus, pole is like here, so this is the focus, so that will also be plus f. So this is the basic of sign convention. You should maintain it while doing the numericals, otherwise numerical results will not be matching with that of the actual answer. So now I go to the mirror formula, standard formula that we do have, and you have already done it in the class 10th syllabus. That is the 1 by v plus 1 by u 1 by f. This is the basic formula. Now remember one thing, when you go for numerical solutions you have to use this formula, then you again have to use the sign convention here. Suppose I use this formula where the distances are given here. You say this is 20 centimeter, image is at, say I tell you 10 centimeter, focus is 30 centimeter. These are the values given. Now if you put in this equation, suppose I have to calculate the value of f. So I will do v, the value of v and value of u I have to put. Now what I will do, you see now v is plus, so I will use plus 10, u is negative, so I will use minus 20, that equals to 1 by f. So if I calculate this value f, so what exactly the value comes? So So the equation becomes 1 by 10 minus 1 by 20 is equal to 1 by f. So f is equal to 20 centimeter. Now you see the focal length of convex mirror is plus, positive. That's why, as I have used this sign here already, that's why the value came as positive. So this way you have to use the values in the equation including the sign convention. Remember, you use the values along with sign convention, otherwise the result will not come. So this is the relation between image distance, object distance and focal length of a spherical mirror. Now how you can draw a image of convex or concave, whatever it may be, how you can draw a image, because you have generally you are having 5 different places where you can place your object. Suppose you are having a concave mirror, so this is the axis, this is the F, this is the R, this is the pole. Now you can put your object here, or you can put your object on the R, or you can put your object between R and F, you can put your object on F, and you can put your object within F. So I can write U can be greater than twice F, U can be equals to twice F, can be less than twice F, greater than F, U can be is equal to F, U can be less than F. So for this 1, 2, 3, 4, 5 different places of object placement you can have image. On the contrary, if you go for convex mirror, wherever you put your object, you see convex mirror is like this one, okay? You are having F, this is R, this is F, this is O. Now you cannot put image inside the mirror. Is it possible to put a object inside the mirror? Say you take the example of our normal glass looking mirror, plain mirror. You cannot put an object inside the mirror. Whatever you do, you put your object in front of the mirror, so you get the image. So wherever you put your object, here or here, whatever may be the distance, every time it is image virtual and also smaller in size. So these two things happens for convex mirror. Wherever you put your object, you put your object here or here, all the time you will get the image like this. Obviously for different places of position of the object, the height of the image might be varying, but it is always less than the size of the object, and it is also always virtual. So that's why these 5 cases does not apply into convex mirror. No need to go for that. Now how you can draw a image? Suppose I am taking you say this case where I will be having my object beyond 2F. I am having my object here. Various methods are there in books. Lots of methods, they will be giving you idea how to draw the image, but according to me, one thing is very easy to draw, that is a ray coming from the object passing through the focus after reflection becomes parallel. Okay, it's very difficult to draw without a scale, but only assumptions I am doing. And parallel ray coming from the object after reflection, I think this side has gone little bit upward, so it will be after reflection it passes through focus. So this ray coming from the object, this is your object, mirror reflection, then goes parallel. Okay, one rule. Second rule, the ray coming parallel to the axis after reflection, they passes through the focus, and where they meet, that intersecting point is the image. This is my image. So this is the easiest way to make a object an image in case of mirror. Wherever you get, this is the basic rule. Now if you go here, this case, let me clear the board. Let it be F here, it is F and twice F. This is a concave mirror. This is so I am putting my object here. This is my object. What was the first rule? Rays coming through the focus will be parallel after reflection. So let me draw the first thumb rule. Then it becomes parallel. So first rule I have applied. The second rule is the rays parallel to axis after reflection, it will be passing through the focus. So let me draw parallel line. So this is the second law I have applied. Now the intersecting point is here, so make a perpendicular from that point, it will be your object. This is my image. So till now I have discussed about two rules. One is the sign convention rule, another one is the how to find an image position of a given object position. So in any case you can draw and find the image, and as per accordance you can use the sign convention. So these are the two thumb rules I have told. For one case there should be an exceptional case I will call. the thumb rule is not applied here blindly. We use the rule, but it is not used as blind application. So what we will do here, now the object I will put, say this is the F, this is the twice F. Now I have this again concave mirror pole. So I have put my object here. So what was the case? Now it will be U will be less than F. This is the case. Now one rule I can apply, say the parallel rays coming from the object after reflection, they will pass through focus. Fine. The second rule was the rays coming through focus will be parallel after the reflection. Now you see, if you give this line, you will never find the mirror here. So there will be no question of reflection if a ray coming through the focus. So there what we will do, we will took this line, which is now you make it so you get here is your image. So this is my object. So there the rule is that if you have a circle, if you take a small segment, the rays coming from the radius of curvature or the radius will be again retracing its path through the radius. That is the rule I have used here for this line. This ray is for passing through say radius of curvature. So this is the way I will be making the image. Now you see the sign convention. If I apply, this is U, it will be negative because I am going against the incident ray. The focus as it is negative because I am again going against the incident ray. But the object, image distance, which is V, this will be positive. Why? Because I am coming in favor of that incident ray. So if you use this type of values of U, V and F in the standard equation, what will be your, this will be plus V minus U minus F. So you use this sign convention, then you go for calculation, your result will be quite correct. Otherwise this result will not be as expected in the correct form. Sign convention is very important. So these are the things about spherical mirror. Obviously one factor is there, this is called magnification. Magnification is nothing but, this is called the magnification. Also called Vivardhan. So magnification is equal to the image height by the object height. That means how much larger the image will be. So the image might be larger than the object, it might be equals to the object, it might be smaller than the object. So through these parameters I will be saying that the magnification is denoted by M, which is equal to image height by object height, which can be with a minus sign, it can be minus V by U. So you need not to go through the derivation, just you know the formula, because all these things are being done in the class 10th. Okay, I am just recapitulating all these ideas. So this is the thing about spherical mirror. Now you go for the numericals and numericals you use this formula, and another formula is R is equal to 2F. So these two basic formulas are there only, and you go for the solving the numerical using those formulas. So reflection part, I think if you remember your class 10 topics and the things which I have discussed right now, I think it will be sufficient. Then you go for the problems, you solve it, and if you have any problem, then share it, the problems. Okay, now I am shifting my topic to refraction, which is very important because this ray optics is based completely on refraction in your syllabus. Refractions means প্রতিসরণ. So this is the refraction. Now if I say define the refraction, how you will define? Say here is a medium of A, let it be here, okay, and here is the medium of glass. Okay, let me clearly write this glass. So there is a two medium, and this is called the interface of the medium. This line is called the interface, I mean the boundary. In physics the boundary is called the interface. This is the interface, this boundary. So a ray is coming. So until now this ray of light has traveled through air. Once it get into the interface, it finds a different medium in front of him. Now what will happen? Suppose you are walking on a plain road. Suddenly you find some sand. So your speed will be decreased. You cannot move on as fast as you have been in the plain road and same velocity within the sand. So your speed will be decreased. So the medium is changed here. The medium changes means the density of the medium has been changed. I am going from rarer, this is rarer, and this is denser medium. So I take a normal being drawn at the interface where this, now it should have come in this way. If the medium glass is not there, the ray should have come in the dotted line. Now as the glass is there, it will bend in this way. Okay, this bending, you see the bending is done at the interface. That bending is called the refraction. So I can define it, bending of light. Remember, bending can be done without the interface. Bending can be done also without the interface. In a simple medium, single medium light, bending can be done, and that is called the diffraction, which is not, I am not discussing right now. So bending of light at any interface, that is boundary. that is called refraction. If there is no medium change, there will be no refraction. If there is a medium change, only then there will be a refraction. So I am drawing three diagram. Okay. Say this is air, glass. So one ray is coming here, then another ray, now which diagram is correct? There is a bending of the, say if I say ray 1, 2, 3. Both of us are bending, there is a interface of two medium. Now which ray diagram shows the exact of refraction? What was the definition? Bending of light at any interface. The bending should be at any interface. Remember, not inside the interface, not outside, only at the boundary. So this is wrong. This is not in refraction. This is also not refraction. This one is the correct one, because here inside the medium there is a bending. Here above the medium there is a bending. This bending is only at the interface. So this one is the correct ray diagram of refraction. Now if you say that in the beginning I have told you the Euclidean geometrical concept of ray optics. So one thing you can be sure yourself, that retracing of the path. Let me show. So this is the retracing of path I am considering, because in case of refraction or mirror, lens, prism, everywhere you will find this method. Because refraction, you see, you have a glass slab, so you can see the object from your side, keeping the object in the opposite side of the slab. Simultaneously, if you interchange the image and the object, the same thing will happen. So now my ray is coming from rarer to denser medium. If it goes from denser to rarer medium, same road will be taken. If it goes from this, then it will be like this. This is called the reversibility. Retraceability or reversibility, whatever you tell. So in case of reflection also, in mirror also, you can have the reversibility of light. And also for the refraction you will have this reversibility. This is very easy things. Now main thing is that now the bending, I am not drawing the bending as per my choice. Size does not belong to anyone's own choice. So what I am doing this bending because I have the law, I know that law, how to bend and how much extent I will bend. It is not like that I can bend like so. This is the reversibility factor, means the light can retrace its path. Okay. Now the bending I cannot do at as much as for my own choice. I cannot bend it like this or anyone coming bending like this. No, this is not quite correct. How to measure the bending? Because I have a factor called mu. This is called refractive index. We call it refractive index. This mu is the important factor. That mu decides how much bending there will be for any given two medium. Now how to determine the mu? I cannot assign any values to mu. I cannot give any value to mu for any of the two medium given. So what will be my question, that how the value of mu is being assigned? Now the mu has a very beautiful definition. Mu is, in your books it is also written as n. In your book it is written n. In NCERT textbook it is written n. In some other books it is also written mu. Whatever it may be, this is equals to velocity of light in air and velocity of light in medium. Now velocity of light is fixed in air. It is given as c. C has a value 3 into 10 to the power 8 meter per second. So it is the fixed value. And the medium, if it is glass, that will be Vg. Let it be. So for a given medium, these two values are constant. So you cannot change those values. So indirectly this mu and n also becomes constant. Now you see, I have given a medium air. In my previous diagram it was like air and glass. Now if I apply the same concept, so for this case, let me concise the thing. Mu is equal to C by Vg. Now if I give another medium where it is water and glass, then mu will be velocity of light in water and velocity of light in glass. So I have replaced this air by water. So it becomes like this. So it will be VW by Vg. So up to this I am concluding. Next day I will start from these two relation. What is the difference between this mu and this mu? Okay, go through the topic. Next day I will be going into the deeper segment of the refraction. Thank you.